All right, let's talk about the language of the digital world. All the data that makes everything tick. We're going to go on a journey, starting with the absolute smallest spark of information and scaling all the way up to the giant data centers that run, well, pretty much everything. So, yeah, let's just dive right in. So, you've seen these, right? KB, MB, GB, TB. They're plastered all over every new phone, every laptop, every hard drive you buy. I mean, they're everywhere. But what do they actually mean? Well, stick with me, because by the end of this, you're going to know exactly what's going on under the hood. Okay, so where do we start? We have to go all the way back to the beginning. The absolute most fundamental piece of digital info. You can think of it as the atom of the entire computer world, and it's called the bit. And bit is literally just short for binary digit. That's it. It's the most basic, fundamental building block of everything digital. Seriously, every photo you take, every email you send, every video you watch, it all starts right here with bits. So here's the key, the thing you really need to get. A bit can only be one of two things. It's either on or off, a 1 or a 0. That's it. Just think of it like a light switch. And this super simple two-state language, well, that's how all computers understand and process absolutely everything. Okay, so a single light switch is cool, but you can't do much with it, right? To do anything really useful, we need to start grouping these little guys together. And that's how we build our next block, something way more powerful, the byte. So what's the magic number? Well, in pretty much all modern computing, it's 8. For decades, really, this has been the standard. You take 8 of those little on-off switches, you put them together, and suddenly you have enough different combinations to start spelling things out, to represent stuff we can actually recognize. So 8 bits, that equals 1 byte. And with just 1 byte, you suddenly have the power to create a single character. We're talking the letter A, or a question mark, or the number 5. This is that first huge leap, from just a bunch of ones and zeros to actual real information. All right, hang on. Before we go any further up the ladder, we gotta solve a mystery that I'm sure you've run into. You go out, you buy a brand new 1 terabyte hard drive. You're all excited, you plug it in, and your computer says you've only got 931 gigabytes. What gives? Are they ripping you off? The short answer is no, not really. It all comes down to a little bit of math. See, what's happening is that the people who make the drive and your computer are speaking two slightly different languages. The manufacturers, for their marketing, they use nice, clean, round numbers, base 10. For them, 1 kilobyte is 1,000 bytes. Simple. But computers, they think in base 2, powers of 2. So for your computer, a kilobyte is actually 1,024 bytes. And that tiny difference, well, it really starts to add up when you get to gigabytes and terabytes. That's why your operating system always shows less space than what's printed on the box. Okay, mystery solved. Now we are ready to really start climbing. We're going to scale up from that single byte to the units you see all the time, every day. Kilobytes, megabytes, and gigabytes. So, first step up is the kilobyte, or KB. And remember our computer math, right? That means it's 1,024 bytes. Now, let's be honest. In today's world, that's a pretty tiny amount of data. So what is a kilobyte? Well, think of it as enough space to hold maybe a paragraph of text, a short email, that kind of thing. A whole page of just plain text, that might be somewhere around 100 kilobytes. All right, let's take another big jump. You bundle up 1,024 of those kilobytes, and what do you get? You get 1 megabyte, or MB. And now we're starting to talk about file sizes you deal with every single day. A megabyte is way more substantial. It's roughly the size of a high-quality song, an MP3, or a single, nice, high-resolution photo from your smartphone. Just for fun, back in the day, an entire floppy disk, you remember those, could only hold 1.44 megabytes. Kind of crazy to think about. Next up on the ladder is the gigabyte, GB. This is a big one, 1,024 megabytes. And this has really become the standard unit for almost everything. Your phone storage, your monthly data plan, how big a new app is, it's all measured in gigabytes. So how big is a gigabyte, really? Well, it's big enough to hold an entire full-length movie in standard def. Or if you want a physical comparison, it could store all the text from about 30 feet of books on a shelf. Yeah, we are definitely dealing with some serious capacity now. But you know what? As big as a gigabyte is, we now live in an age of truly massive information. So now we have to move into the realm of big data. We're talking about terabytes and the mind-bogglingly huge petabytes. Okay, a terabyte, or TB, that's 1,024 gigabytes. And the scale here just gets staggering. Get this, just 10 terabytes is enough space to hold the entire printed collection of the Library of Congress. The entire thing. And the wild part is, you can go buy a hard drive that big for your home computer right now. So where do we go from there? I bet you've figured out the pattern by now, right? To get to the next level, we take another one of those giant leaps, we multiply it all again by 1,024. And when you have 1,024 of those huge terabytes all together, you get 1 petabyte, PB. Now, this is a word you're not going to see when you're shopping for a laptop. This is the language of huge tech companies, of cloud storage, of the massive data centers that power the internet. Trying to even wrap your head around a petabyte it's just mind-bending. But let's try. Imagine 20 times million of those big 4-drawer filing cabinets. Okay, all of them stuffed completely full of paper. A single petabyte could hold all the text from every single one of them. It's just an absolutely unbelievable amount of information. Wow. Okay, so we've covered a ton of ground here. We went from a single light switch all the way to millions of filing cabinets. So let's pull it all together into one simple cheat sheet just to make sure everything sticks. So here it is, your quick reference. A bit, that's your light switch. A byte, a single letter, like A. A kilobyte, just a paragraph of text. A megabyte, think of a song. A gigabyte is a movie. A terabyte, that's your personal hard drive. And a petabyte, that's a giant data center. That's it. That right there is the language of data, from smallest to biggest. You know, it's incredible. We went from bits to petabytes, basically within a single human lifetime. But it doesn't stop there. Oh no. Scientists in data centers are already dealing with exabytes, zettabytes, and even yottabytes. It just makes you wonder, with data growing this fast, this exponentially, what are these incredible new scales of information going to let us do next? What's just around the corner? Pretty cool to think about. Thanks for joining me on this one.